Many acids contain 2 or more hydrogen ions that can dissociate. So sulfuric acid, the H's we can actually give off. H2CO4, SO4, sorry, is the formula for sulfuric acid, which means it can actually give off 2 hydrogens. Right? When it gives off those 2 hydrogens, it's able to give off 2 protons. So when it dissociates, right, the first time it gives off 1 hydrogen proton. Who's it going to give it off to? The water. Which leaves us with the HSO4 -1 because we've given off 1 proton. This sulfuric acid is considered a strong acid. Right? As I've shown you guys in the list of strong acids on one of the earlier slides. Now, it dissociates once, but it has the ability to dissociate again. So we can still remove this hydrogen and give off another hydrogen to a water molecule, to another water molecule, forming that another hydronium ion. Right? The only thing is now this is considered the strong acid, but when we dissociate this one, okay, it's considered a weak acid. Okay, so the resulting aqueous hydrogen sulfate ion, HSO4, considered a weak ion. So when it dissociates, right, so here's now the weak version of the acid, but it's in ion form. It also can give off the hydrogen proton to a water molecule, forming the hydronium ion, right? And then giving way to the sulfate ion. Now, notice here one of the differences, what I've used. Arrows going back and forth. What it means is this reaction is actually reversible. So as quickly as this is able to dissociate into this and this, right, these same 2 things will come together to reform the weak acid. So it's kind of, it goes back and forth. It's kind of like they come apart and then they come back together. Go apart, come together. So this is reversible, right? And so you'll see arrows that go back and forth, or you'll see the arrow just going in one direction. Right? So this is, okay, when this dissociates, it's a strong acid, they will all dissociate this way. Right? Then this will dissociate again, but it's reversible. It goes back and forth because it is a weak acid. Acids that contain 2 hydrogen ions dissociate to form 2 anions. These acids are sometimes called diprotic acids. So we've got the monoprotic because it can give off 1 proton. Diprotic because it can give off 2 protons. So sulfuric acid, one of the examples. Carbonic acid, another example. Right? Anytime you see H2 with the formula for an acid, it can give off those 2 hydrogen protons. So the acid that is formed in the first dissociation is always stronger than the acid that is formed in the second dissociation. So even though an acid might be a weak acid that has the H2, that first dissociation is always going to be still stronger than the second dissociation. So that acid that it forms, the first acid is always stronger. Right? So once it dissociates once, that acid is still stronger than the new ion that it forms. Acids that contain 3 hydrogen ions are called triprotic acid. Common one is phosphoric acid, H3PO4 in aqueous. Right? So here we have H3PO4. We can give off 3 hydrogen protons, okay, when we dissociate it in water. So we have the following. H3PO4 is going to give off the hydrogen to the water to form the hydronium ion. Right? But when it dissociates here as follows, we form this ion. This ion still has 2 more hydrogens that it can give off. So what's going to happen is in a water solution, right? And I just kind of, what I've done is I haven't shown the hydronium ion in these examples. I just wanted to show the dissociation of the hydrogen proton. So we've got the hydrogen proton being given off, right? And pretty much it's tacking onto water. But it has the ability to give off 2 more, right? So we have the following. So here we have the ion that we formed in this first one, this first dissociation. So now this second one is going to give off 1 more, right? So we've given off, which means I still have 1 more proton that I can actually still dissociate. I can still give that up. So what's going to happen is this is going to dissociate again. Okay. So we have a total of 3 hydrogen protons that we can actually give up. That will give up to a water molecule forming the hydronium ion. Right? But as we said, the first one is always considered stronger than the second acid. This second acid is still stronger, even though it's weaker, than this one. So this first reaction is more likely to happen, and then all the others, make way. But again, notice how they're reversible. So the acid that is formed by the first dissociation, as I said, stronger than the acid that is formed by the second and then by the third. So the third would be the not as strong, the acid for the dissociation. First one's always the one more likely to happen, and then the others are always usually reversible.